Everyone, I'm going to show you a 3-AND gate socket, how to simulate a 3-AND gate socket with Multisym. So without wasting time, let's go on the simulation and see what is going to happen. So you see all these lights are off, X2, X1, and X4 and X3. They are all off. But once I turn on the socket, so when I switch on the socket, some of the lights are going to go on. So now let's see what will happen if I switch on S1. You see the first bulb, only the first bulb, S2. Hello everyone. We are going to look at the 3-AND gate socket using Multisym. The socket is already drawn for us. We have four inputs. Four bulb with 4 switches, and as well as 3 resistors and 1 AND gate. 3 input, 1 AND gate. So we are going to see, okay, as you can see here, all these lights, X2, X1, X4, X3, they are all off because of the switches that are turned off. But once I turn on switches, only some of the specific bulbs will go on. Why do we think that is the case? So now we are going to check the simulation, what will happen if I press the switch. So without much wasting time, you press on the play button to see how the simulation goes. So I turn on this first switch. As you can see, X2 bulb went on, and it's only the one that went on. Why do you think that is the case? Because as you can see, X2 is attached to the switch. Only X2 alone that is attached to this switch. So therefore, it is not going to have any effect on other switches. You understand? So, but when you turn on this one, it only go on itself as well, because this switch is attached to this bulb, because the other one is also attached to that bulb, but there are also others that are attached to it, so it cannot go on. So, but if I turn on this one, which bulb do you assume it will go on? X4 or X3 or all of them? So to me, I think it's all of them, because as you can see on the socket, you have this wire connected to this bulb. So, and it's also connected to the switch, and this wire connected to this one that is already on, so it will go on, obviously. And this middle one connected to this one, and it's already on, so it will also go on. So obviously when I turn on, both of them will go on because all the bulbs are on. If you know the rules of an AND gate, when all of them, at least one must be high for the rest to be high. And this one, all of them, they are high, so it's obviously it's an obvious case that it will go on. So that was just okay, but let's try to switch off the two. See, they went off, and only these two remains. Why do you think that's the case? Because sorry, there was a misconception there. Okay, only these two remain. Why do you think that's the case? Because this switch is connected to this resistance, and as you go towards to the left, you see this last bulb that is on is also attached to this 3-AND gate, and they can, if one of them is on, the other one can also be on. So without wasting time, let's continue to the other example. This one, I'll first of all, let me just stop this one. So in this example, we are going to look at a Multisym socket, graded socket with an OR and AND gate with 2 AND gate and 1 OR gate. So the socket is already constructed for us. We want to create an simplified expression of this socket, and also to give the output of the truth table. So now, having to be given already the socket that is created for us, let's double click on the logic converter to get our truth table generated for us or displayed for us. So as you can see there, the logic converter has 4 inputs, binary numbers, and outputs. So now you click on the conversion panel. You click on this panel where I'm pointing. Just click it. You can see this is the expression of this whole socket. It's not simplified, as you can see, but once you press on the one below it, it will give the what do you call the simplified expression of that socket. So, and once you double click this one, it will generate a socket based on a simplified expression. Where can I place this one? It's got to be, yes, let's place it here. So this, you see this socket, this is now a simplified expression of the bigger socket. So without wasting time, let's continue to the other one. The other one, why am I forgetting to stop first? First of all, you need to stop. Or is it stopped? Okay. This other one socket, it's the same as the other one. Just the same. You click on the double click on the logic converter so that you can get our truth table generated for us. So then you continue to press on the second panel, in the conversion panel. You press that button, then you can get the output of the long expression of that whole truth table or socket. So now we can have this one. We have this one. So as we have this one, you see, it's a sum of product, which is a SOP in a short way. So now we need to get this SOP, a simplified expression of this SOP. So we go here. This is a simplified expression now. AC plus B. So now we want to know how would the socket look like of that how would the socket look like of that simplified expression? Just click there, then it will be already be generated for us. You see, this whole long socket, it was simplified in a just small, very small. So it's best. So therefore it's best if we can get our socket always simplified. With me, Gustav Kaminike Hange. That was a few description about the usage of Multisym to create or generate simplified truth table or generating sockets with different types of logic gates. So thank you so much for watching. I thank you.